Alright, so for number 13, solving systems of equations. This is where you got to use your Algebra 1 skills of factoring and also knowing your unit circle. So, you're given two equations that are both equal to r, so you basically just set those equal to each other. In this case, my 5 cosine theta is on both sides, so those are actually going to cross out. So in this case, I'm just left with 1 equals 4 cosine squared of theta. Now my suggestion is you always just get everything on one side, set it equal to 0, and factor it. That's the easiest way when you have a quadratic. So in this case, I have 2 cosine theta plus 1 and 2 cosine theta minus 1, because you should recognize this pattern as a difference of squares. So now I have either 2 cosine of theta plus 1 equals 0, or 2 cosine of theta minus 1 equals 0. Solving each of these equations for cosine of theta gives me negative half and positive half. So in the unit circle, cosine is negative half and positive half at 60, 120, 240, and 300. So now, there's several ways to now find the points of intersection for these two equations. You can plug them in your calculator and look at your table of values to build your table, and it'll give you all of these r values. Or you can just evaluate these equations for each of these values. Again, it's probably quicker to go ahead and plug them in your calculator. For the second one, same thing, except for you're looking when you factor 2 sine squared theta plus sine theta minus 1, you get 2 sine theta minus 1 and sine of theta plus 1. Setting each of those equal to 0 and solving gives me sine of theta equals 1/2 and sine of theta equals negative 1. So now if I take the inverse sine of both sides, that gives me 30 degrees and 150, because you have to think on your unit circle, when is when is sine going to be 1/2, and that's at 30 and 150. Sine is negative 1 at 270, so again, plugging those values in your calculator, looking at your table of values gives you the points negative 630, negative 6 150, and 0 270.